new topic, graphs. How do we define a graph? How do we define a graph? Graph G is defined as V comma E, where graph G is defined as V comma E, where V is set of vertices and E is set of edges. V is set of vertices and E is set of edges. Every edge is defined as the pair of vertices on which it is incident. A graph is said to be a simple graph. A graph is said to be a simple graph if it does not have self loops and parallel edges. If it does not have self loops and parallel edges. A graph is said to be connected. A graph is said to be connected graph when there exists a path between every pair of vertices. So for example, consider this graph, and this graph can be represented internally by what is known as the adjacency matrix. First of all, let us write down the vertex set of it, which is V0, V1, V2, V3, V4, V5, V6 and V7, whereas the edge set will be V0, V1, then V0, V2. From V1 we have V1, V3, V1, V4. Then from V2 it is V2, V4. V2, V0 is already there. Then from V3 it will be V3, V4, V3, V5, V3, V6, then from V4 it is V4, V5, V4, V6, From V6 it is V3 and V4, that is already shown, and from V5 it is up to V7. So there are as many as 11 edges. You can check the degree of each vertex, like V0 has got degree 2, V1 has got degree 3, V2 is degree 2, V3 is degree 4, V4 is degree 5, V5 is degree 3, V6 is degree 2, and V7 is degree 1. So the sum of degrees of these vertices, 2 plus 3, 5 plus 2, 7, 11, 16 plus 6, 22. And we know by handshaking lemma that sum of degrees of vertices is nothing but twice the number of edges. So there are 11 edges and the sum of the degrees is 22. Now when this graph is represented internally, we will use adjacency matrix, which is a matrix of vertex versus vertex. It is V0, V1, V2, V3, V4, 5, V6 and V7. So there are edges from V0 to V1 and V2. From V1 it is V3, V4. From V2 it is only V4. From V3 it is up to V1 is already shown, then V4, V5, V6, V4, V5, V6. From V4 it is V1, V2, V3, V5 and V6. So it will be V5 and V6. From V5 it will be now V7 only. And from V6 we have almost shown all of them. This is what we call it as the adjacency matrix. It is called as the adjacency matrix. Make a note. Draw that graph. The vertex list, there are in all 8 vertices and as many as 11 edges. Graphs is the topic which you have already learned in discrete maths. These happen to be the degrees of the vertex. You can also observe that in this matrix, if you take the sum of all the elements in any row, you will get degree of that particular vertex. Like sum of row number 0, there are only 2 ones, so degree is 2. So if you take sum of any row in this particular matrix, then you will be getting the degree of the corresponding any row or any column, of course. Write down. If the graph is directed, the edge list will be ordered pair. The edge list will be ordered pair. For undirected graph, the adjacency matrix is always symmetric. When there are no self loops, all the diagonal elements of this matrix will be 0. All the diagonal elements of this matrix will be 0. Self loop will add 2 to the degree. Self loop will add 2 to the degree. In case of parallel edges, value 1 will be changed to the number of edges. So if there happens to be some parallel edge between 3 and 5, then in that case 3-5 position will have value 2, as well as 5-3 position will have value 2, indicating that there are 2 edges. Of course, we are not going to deal with we will be dealing actually with only the simple graph. So there is no question of having any self loop or parallel edges. Okay, right now. To read the graph from the user. Steps. Number 1. Matrix G represents adjacency matrix. Matrix G represents adjacency matrix and is passed to the function. Number 2, accept number of edges n. Say n. Step number 3, initialize n rows and n columns of G. Initialize n rows and n columns of G by 0. Step number 4, accept an edge from the user. Say I, Z. Next step, increment Gij, that is G square bracket I square bracket J. It's two-dimensional array. Increment Gij and Gji and Gji. Next step. Ask for any more age. Ask for any more age. Step 7. If yes, go to step 4. Next step, return n. Stop. So the function that you are required to write in this case will be int type read graph, and it will be a matrix G, which is defined earlier as size by size. This is how you are required to write the function. Okay, user is not going to input it as a matrix. User will not input it as a matrix, because otherwise user will have to go for all the paperwork and write this matrix. User will simply see the graph, user will look at the graph, will enter the age as say 1, 3 and will tick mark. So in a way you will receive that particular position 1, 3 and then you will increment it. I have specifically said it as increment. That means if by chance user gives multiple age, the same age is entered once again, say 3, 1, then it will automatically become 2, because we will be considering it as another age, parallel age. So it is possible, if you check the adjacency matrix fully for all the diagonal elements in this adjacency matrix, if you see that all the diagonal elements are 0 and all other positions they can maximum contain value 1, then you can straight away say that the graph is simple. Okay, so we can even have one more function to check whether the graph is simple. To check whether the graph is simple, and this function I want you to write, जिसे आप G और N पास करोगे. Okay, I have already said that you will have to check all the diagonal elements to be 0 and all other elements should be either 0 or 1. Okay, लिखो. दो फंक्शंस लिखे आप, रीड ग्राफ एंड इज सिंपल. You will have to simply initialize it to zeros. For I equal to 0, I less than n, I plus plus. For j equal to 0, j less than n, j plus plus. G of ij is equal to 0. Initialized. Printf, how many vertices? Actually that you should do first, no? It should be done here. Read those number of vertices n, and then you will ask for what is the age. That age will be given to you as pair of vertices, that is I and j, and then you will say G of ij plus plus G of ji plus plus. Printf any more and do from here while get ch is equal to y. Return n. सब कुछ तो दिया था वो. A simple straightforward function actually. मैट्रिक्स क्यों रीड करना है आपको? All the things were given to you directly. Everything was given to you. Kya hai? Right. Okay, let us write the function is simple. It is int is simple, to which I will be passing the matrix G, adjacency matrix, and number of vertices n. It is int I j. For I equal to 0, I less than n, I plus plus. If g of ij, rather if g of ii is not equal to 0, return 0. If the diagonal element is non-zero, it's not a simple graph. Okay, otherwise I will simply check for I equal to 0, I less than n, I plus plus. For j equal to 0, j less than, n, j plus plus. If g of ij is greater than 1, return 0. Otherwise, return true, that is 1. But observe that here also I am going through the diagonal elements, so probably I can omit this loop. Diagonal element cannot be 1 first of all. It will be always 2 if self loop exists. So any value greater than 1 will make that graph as non-simple graph. So even this need not be written. You can directly have this. If you find a value which is greater than 1, return 0, saying that it is not a simple graph. In this case, it will go through all the positions, checking 0, 1, rather value at every position in this particular matrix, and it doesn't find 2 or any other value here. So ultimately it will go through this entire loop. This return is never executed, this condition is never true. One on diagonal does not exist, because on diagonal, suppose 2, 2 is the entry, then you are saying that g of 2 2 plus plus, and again g of 2 2 plus plus, g of ij plus plus, g of ji plus plus. So it will be automatically becoming 2. It cannot find 1 on the diagonal position. Okay. Next job. You have taken this down? It's a simple function actually. Write down. Breadth first search of a graph. Breadth first search. BFS. Now in this case, let us start with some vertex, say V1. If I start with V1, I will have to mark all the vertices which are adjacent to V1. I will have to check all the vertices which are adjacent to V1, namely V0, V3 and V4, and they should be shown on the next level. So it will be V0, V3 and V4. I am just drawing the graph in a different manner. Now from V0, one edge goes to V1 and other goes to V2. So from V0, V2 at the next level, not at the same level. Then from V3, there are edges going to V1, which is already shown, edge going to V4, which you can just show horizontally, V4, and edge going to V5 and V6. So you can have V5 and V6 at the next level. So all the edges of V3 are shown. All the edges of V4 now. All the edges of V4. Out of that, up to V1 we have already shown that edge. V3 is shown. We are now required to show it till V5 and V6. So coming back to this new figure, from V4 to V5, from V4 to V6. And V4 to V2 is also there. Okay, fine. V2. We come to the next one. I am just moving horizontally. From V2, all the edges are shown. From V5, there is edge till V3 to V4 and V7. And from V6, all the edges are shown. From V7, all the edges are shown. So I am just changing the orientation of the vertices and drawing the same graph. Actually, if you recall, these two graphs are known as isomorphic. These are isomorphic graphs. Anyway, so you will have to start with the given vertex. All the adjacent vertices of it are put on the next level. Unke adjacent vertices on the next level, like that. And then if you print this sequence horizontally, which will turn out to be a sequence like V1, then V0, V3, V4, then V2, V5, V6, and then V7. It will be called as the breadth first search of the graph, starting with vertex V1. Just print it level by level. In this case, we don't have any levels as such, because the graph was not drawn in that particular manner. This graph is drawn in a totally different manner. We are just rearranging it. Got the concept? Now, to do all this job, see how do we proceed. Let me write it here only, so it will be side by side. I will maintain a queue. It was, now don't look at the figure, neither the first given figure or the new one. We will be only looking at the adjacency matrix, because in the program what you can see is only the adjacency matrix. This represents the complete graph. From here we are required to get the required output. So we start with the given vertex, that was V1, and I put it to the queue. I just put it to the queue, given vertex. It is directly given by the user. I remove it and print it. And then go to the row of V1, checking for all ones into it. And whenever I find one, like V0, V3, V4, in sequence I will put them to the queue. So it is V0, then V3, V4. Okay? And then again repeat the procedure. Remove V1, print it. Remove V0 and print it. Now go to the row of V0 and check for ones, V1. Now the problem is V1 was already there in the queue. So it should not be again put back. Right? So I will take help of something called as one more array actually, which I will be naming it as visited. 0, 0, 0, 0 means false, means not visited. Vertex 0, 1, 2, 3, 4, 5, 6, 7. When I put V1 into the queue initially, I will set visited of this to true. Initially 1, okay. Initially V1 should be set to true. Then when we put V0, V3, V4, we will have to set visited of 0 as true, visited of 3 as true, visited of 4 as true. So they are visited, that means they are already put into the queue. Now when I start with row corresponding to 0 and I check that there is 1, okay, but 1 is already visited, so we will not be putting it to the queue. We proceed V2. Okay, it is not visited, so I put V2 to the queue and mark it as visited. I proceed further, there is no other entry of 1. Okay, so the job is done. We again remove the next one from the queue, V3, print it. Go to row for V3. V1 is already visited, V4 is also visited. What was this? So 0 only? No, 1 था. V5 is not yet visited. V5 is not yet visited. So we mark it as visited and put it to the queue. V6 is also not yet visited. Mark it and put it to the queue. Then I go to V4. I remove this V4, print it. Go to the row of 4. V1 already visited. V2 is also visited. V3 is visited. V5 is visited. V6 is visited. There will not be any entry going to the queue. We remove the next one, V2, print it. We go to the row of 2. V0 is already visited. V4 is also visited. We remove the next one, V5, print it. V3 is visited. V4 is visited. V7 is yet to be visited. So I mark it as visited, put it to the queue. Then I remove the next one, V6, print it. There are entries for V3, V4, both are visited. I remove V7, print it. There is entry for V5, which is already visited. Queue becomes empty, we stop, and what we get over here is the same sequence, BFS. Got the procedure? First we will take down the procedure and then you will draw this particular graph and then carry out this procedure. I will be changing the starting vertex. पहले आप ये करो, then I will give you one more vertex जिससे आपको BFS लिखना है. Okay? Right now. Steps for BFS. Create one array visited. Create one array visited and initialize it to 0. And initialize it to 0. Next step. Accept the start vertex from user. Say I. Next step. Set visited of I as true and add I to the queue. And add I to the queue. Next step. Delete a vertex from the queue. Say I. Next step. Print I. Next step. In adjacency matrix, in row number I, check for value 1. Check for value 1. Say present at column Z. Say present at column Z. Next step. If zth vertex is not visited, mark it as visited, and add it to the queue. Next step. If queue is not empty, then go to step जहां आपने लिखा है delete a vertex from the queue, उस स्टेप को जाना होगा. And next step, stop. This will be the algorithm for BFS of a graph using adjacency matrix. Okay, using this, follow this procedure. I have already shown you how to execute it on paper. So I have given you the output corresponding to start vertex as V1. You also give me the output corresponding to start vertex as V6. Yeah. आपको ओरिजिनल तो लिखना ही है, प्लस V6 V4 V1 V5 V2 V0 V7 सबका सेम है. Okay, now let us write the function for BFS. पकड़ मारता है. अगं ए राणी, प्रत्येकीला सांगू काय कानात येऊन गप्पा नका मारू म्हणून. So we will have the array visited Q, front and rear of course corresponding to that Q, and I is the vertex which we want to deal with. So here we'll first ask the user as enter. Actually, what was our first step? Set visited to null or what? Okay, so we'll do that first. So it is for I equal to 0, I less than n, I plus plus, set none of the vertexes yet visited. So all visited are set to false. Printf start vertex accept it as I, mark visited of I as 1, and then add Q क्या लिखोगे add Q में? Parameters are Q comma and rear comma I, and then our procedure starts. It is I equal to del Q, Q comma and front comma and rear, printf I will require J also, no? And then for J equal to 0, J less than N, J plus plus. हेलो, हाँ बोलो. हाँ, yes. If g of ij is equal to 1 and not visited j, in ith row jth column position you have 1 and corresponding visited is 0, so not of 0 will be true. In that case you will have to mark it as visited and add it to the queue. And keep on doing this while not queue empty, which is based on rear, will be the function BFS. That is breadth first search of a graph. Exactly as per the steps that we have written. Now this graph is a non-linear data structure, so we cannot just print the contents. The only way by which you can show the connectivity is through BFS, and there is one more, done depth first search. Depth first search. For simplicity, I will say that this is just for you to remember. Replace Q by stack. अभी जो हमने पूरा फंक्शन लिखा है, that can be converted to depth first search just by replacing Q by stack. Everything else remaining the same. Top equal to -1, comma. All this is same. Instead of add Q, it will be push. It will be stk, comma and top, comma I. Instead of del Q, it will be pop, stk, comma and top, This will be again push stk comma and top comma z while not stack empty top. आपको पूरा लिखना है. You will have to write it fully, one thing, and secondly, starting with vertex v3, tell me what is the output, and again with vertex v6, tell me the output. Procedure वही carry out करनी, but now it will be जब आप v3 से शुरुआत करोगे, तो first of all v3 will go to the stack, v3 will come out, will be printed, and the vertices which are adjacent to v3, namely v1, then v4. हमने पहले v0 से v1 से किया था क्या? Okay, so we'll do it again with v1 so that we can see the difference. Initially v1 will go to the stack, v1 will come out, will be printed. Adjacent to v1 are v0, v3, v4. क्या हो रहा है? v0, v3, v4, yeah. Now v4 will come out, will be printed, and adjacent to v4, v1 is already there, v2 will be now pushed, v3 is already there, v5 will be pushed, v6 will be pushed. Then v6 will come out, will be printed. Adjacent to v6, v3 is already there, v4 is already there, v5 will come out, will be printed. Adjacent to v5, v3, v4 and v7 will be pushed like that. So it will be a different output altogether, called as the depth first search. These are the two ways in which the graph can be printed, or you can reach each and every node of that particular graph. And after this I will be asking one question, as how will you decide whether the graph is connected? We have already written the function is simple. Now it will be the time to write a function is connected. Okay? One of the common problem in the practicals. Job just for 5 minutes. Tell me, how will you check whether the graph is connected? When the graph is disconnected, actually. हाँ बोला. When will you call the graph to be disconnected? छे आम्ही लिहिले सुद्धा मी उशिरा आलात म्हणून. There should be a path between every pair of vertices. There is no isolated vertex into it. This is disconnected graph. Because if you start from some vertex over here, you cannot reach this. This graph is not a connected graph. Got it? Now, if you start with this vertex for BFS, then these two will come into picture, then this. But under any circumstances, इनमें से कोई भी vertex नहीं आएगा. Ultimately, if you perform depth first search or breadth first search, after performing that search, if you find that some vertex is yet to be visited, then the graph is disconnected. In case of connected graph, BFS or DFS will take us to all the vertices. If it is disconnected, then it will print only one component. So ultimately, for checking the connected, or I will simply write a loop saying that for I equal to 0, I less than n, I plus plus, if visited of I is equal to 0, return 0. Otherwise return 1. If all the vertices are visited, then it is connected. Name should be changed to is connected. Job is done. But is connected will ultimately have BFS or DFS into it. This part is important. At the end, check whether all the vertices are visited. If you find at least one vertex which is not visited, still the graph is disconnected. And if all the visited values are true, then you will simply come out and say that yes, it is connected. So it will be int type function is connected. ये सब part वैसे ही रहेगा. Don't change anything. Only a loop is to be added at the end after BFS or DFS. Write only that loop. बाकी सब same ही रहेगा. Where we will stop today. Don't miss next time. We are going for graphs using multi-lists. Right? Today we have considered it using a matrix. Next time we are going to consider it with the help of adjacency list. Adjacency list will be list of lists. So you will have one list where the nodes will be again the lists by themselves. And then you are required to again implement BFS and DFS. That will be the first part of graph. And then we will proceed to trees, etc. And might come back to graphs again to implement Kruskal and Prim's algorithm. Which both the algorithms are there in the syllabus and are very well asked in the practical exam also. Okay, but we will not be considering them immediately. But before trees, one has to consider graphs. So we will have these two lectures, today's and next time. So we will even have list of lists concept also. And then we will directly proceed to trees part.